Hey, Olivier here. Thanks for watching this short video about my first time experience with Meadow on a Project Lab board. So Project Lab is a dev board that Wilderness Labs makes, and it's basically coming with everything you need to get started with Meadow and to learn about it. So that's the board I have. I want to show you what was my first time experience with it. Wildernesslabs.co is where you're going to get all the information you're looking for, and that I'm going to navigate in a second with you. Whether you're a .NET developer or you are an embedded developer used to C and C++, you're in the right place if you want to learn about that first time experience with Meadow, how it looks like. I have a background as embedded developer. I've done C# development as well, and you'll see it's pretty brilliant. Let's get started. So that's the website here, wildernesslab.co. Once again, not a typo. It's .co, not .com. It's pretty cool. Actually, I like the design of the website. But beyond that, they have developers in mind, and all kind of developers. The people developing Meadow, most of them, or lots of them, have been in the team developing Mono, that is behind Xamarin, that framework that allows you to develop cross-platform applications for mobile. Using .NET. Mono is the port of full .NET stack for multi-platform, and that's what's used here in Meadow to bring the entire .NET stack. So I wrote a blog post, first one about Meadow, and so I definitely invite you to go check it out because there's more details. Today we'll look at that first time experience. So with that device, I'm going to go through that get starting guide. You can get started on a Raspberry Pi if you want. You can get started on an NVIDIA Jetson Nano, on a reTerminal, one of these devices here, which is like a Raspberry Pi on steroid, basically. And you can start on your Windows, Linux, or Mac machine as well. If you're developing on one of these, you can use the simulator. It's .NET, it's portable, so you can try it out everywhere. And then Wilderness Labs builds that F7 board. There's a Feather version, really light, and then there's a Project Lab kit that allows you to go beyond in your experimentation with Meadow because it has a bunch of connectors and a screen and buttons and so on. So I'm definitely invite you to do that. I'm on Windows. I have Visual Studio Code, and I'm following the instructions. I installed .NET Runtime. I installed Visual Studio. I added the VS Code extension. Let me show you where you can find this one. So if you go to the extension page, you do a search for Meadow, you will find the VS Code tools for Meadow, install that, and you'll get all the tools you need to do the cross debugging and so on using your Meadow board. And you will be good to go. So when you go back to the instructions, the next steps are about deploying, installing Meadow CLI. So Meadow CLI is the command line tool. Lots of things are happening there. Basically, you can do everything, building your apps, connecting to the board, passing commands there. So it's really the tool you need. And so that Meadow tool, I installed it here. And if you look at the commands, it will give you lots of commands around the app itself to build and deploy it, to debug it. We'll not talk about that today, but command lines to interact with Meadow Cloud, to connect the device to the cloud and being able to verify, to monitor its health and establish connectivity and deploy over-the-air updates and things like that. You have information about your device that you can pull from here. The DFU install. DFU is the flashing tool. You can work around, work with the files, the firmware, reflash it from here, and so on. So that's the ultimate tool you need, Meadow CLI, for working with Meadow. So once you have it installed, once again, Windows, Mac, or Linux, doesn't matter. You can use the exact same tool. The first step when getting the board is to install Meadow OS, or at least the latest version of Meadow OS, which requires flashing the board. It takes about 5 minutes to do the process. It's using the CLI tool, DFU tool I just talked about real quick. You put the board in a bootloader mode and then establish connectivity through DFU to flash the new firmware that you can download. You need to have an account on Wilderness Lab website in order to access to the latest version of the firmware. No big deal here. It will not ask for your credit card. It's just a matter of providing the best support and experience for everyone. And the command line Meadow login for logging in, Meadow firmware download, and then Meadow firmware write to write the firmware to flash the firmware on the device. I have done that so that we could actually go directly to the app development experience. So the first thing that you need to get is some .NET templates. So that's basically the scaffolding for applications. And it's something that, using C# is pretty common, other object-oriented languages as well. So that should be something you're not surprised with, and you'll see is pretty straightforward. So I installed the latest templates. It's actually uninstalling the older version, installing the new one here, 110, perfect. Hopefully I won't discover anything new in between. And once I have the templates, the first thing I want to do, like with every single board, is go through, where am I here? Go through the creation of our first project, okay? So let me go back to my command line here, and I'm going to create the first project. Let me see what I have in this folder here. I only have one project, no big deal. I'm going to do a .NET new project lab demo, right? That's going to be the name of this project. That's basically, if I go to this folder, project lab demo, you'll see a few files. There are the basic ones for the Hello World, and then I will open that in VS Code. Let's see what it says. Okay, I'm gonna do a little zoom in so you can see what's going on. We have several files here, and I walk through these files in my documentation. What I'm gonna do though is I'm gonna connect the board, and I'm gonna deploy this application, the Hello World one, because that's as easy as that. I have the firmware flashed in there. The board is connected. I'm gonna just check real quick that I can see my device manager, the right COM port, the right serial connection, to make sure that my USB device is indeed showing in here as COM3. Perfect. And there's only one COM port, which simplifies Visual Studio Code's life, because if I hit start debugging, it will identify COM3 as the only COM port and will deploy on that COM port. So it's going to build the application. It's going to deploy it. It's going to take some time because that's the first deploy of the application. And so it's going to deploy all the binaries off the runtime, plus the different libraries that the application is using. Not more, just the ones that the application is using, but it's taking a little time, so maybe a minute or so. So in the meantime, what I'm going to do is I'm going to show you a couple of files here that I discovered in the application. The first one is the app config. It's pretty interesting. Meadow will offer a application lifecycle management, restarting an app that fails. There's a level of logging, and then connectivity to Meadow Cloud to do updates of the application or partial updates of your application with libraries updates and so on through the Meadow Cloud. So over the year, pretty practical. Everything is in that config file that Meadow takes into account in the application. Another one is the Meadow config YAML. This other config file is about the network settings or configuration for the device, its name on the network, the use of the ESP32 Wi-Fi chip, so that way you can connect over Wi-Fi, and different kind of information about, you can force DNSs and so on. Last but not least, if you're using Wi-Fi, you can set your SSID and password in one of these config files. So it's pretty straightforward. And then the Meadow app itself, if you've been doing some embedded development or Arduino development, you might be familiar with this notion of initializing the application and then running it, right? Some platforms will use a continuous loop. There's no loop here in Meadow, but there is a run function, right? So the first function that is in all the applications is initialize, is where you set up the hardware, you set up your application, your variables, whatnot. And then there is a run one. So here you see the template has a bunch of things. So that's the run function. What is going on here is that the application will initialize the various sensors that are on the Project Lab board, and then creates a display controller class. That one is part of the sample, part of the template that leverages the graphics stacks in order to write some text on this little display that we have here to display the values of the various sensors on the board. So we'll see that happening in a second once the deployment is finished. Another interesting thing, and I once again dive into the details here into my blog post, but I definitely invite you to check out the Foundation library or namespace, because there's a lot of things happening there. Meadow comes with a lot. And I definitely invite you to go check it out. So let me go to my documentation here, because what I want to show you is in the documentation, Meadow Foundation is where you're going to have all the libraries for the basics of interacting with the hardware, right? There's a peripherals library here with a collection of default or basic type of peripherals. You can see some that are in like LEDs, relays, piezos, and so on. And then there are some libraries and framework that are related to specific hardware. And so I definitely invite you to go check things out here. There is on the Project Lab a set of sensors that are connected, that can be connected through Grove connectors and a couple other things here. You also have a couple of microbus connectors, so you can extend this Project Lab board with a lot of peripherals, and you have all the libraries available for you as NuGet packages. So that's basically, or it's not basic actually, that's what you get there. So let me show you what's going on my device right now. So here you can see that the various sensors are displaying their value here. If I press on the buttons, you'll see that we have a little change over here. If I hover, there's this light sensor. You see the light information is moved, is changed to pretty basic. And you can navigate through that Hello World application for the Project Lab and learn more. Let's go to the next step, which consists in creating my own application more from scratch, right? So if I go back to my command line, where is my command line? Here. One of the templates was the core compute module. It was basically that's the main compute board. So that's something that will give me the basic console application here. If I do a .NET new hello Meadow application, for example, right? And I'm going to use, sorry, that's the name of my application. I'm going to use the core compute module template, and the name of the application is going to be Hello Meadow, right? That is creating a very simple app. If I go in that Hello Meadow folder, I can see the same files I described earlier on, minus the display controller.cs. And if I go and open that, I'm going to have that empty application where basically, if you look at the Meadow app.cs, there is nothing in there. There's the initialize function that is empty, and there's a run function that is empty as well. Okay. And I happen to have a couple of hardware pieces here. One is a little rotary encoder, and I'm going to connect that to one of the Grove connectors, right? So this is Grove is this type of connector that has 4 wires, power, neutral, and then a couple of signals. I'm going to connect it up there in that second slot. It doesn't matter that something is running. What I'm going to do actually is I'm going to stop the debug on the other application. Where is my Project Lab app? It's here. I'm going to stop the debug, close this one. Okay. So this little rotary encoder, I'm going to leave it over there. I need to have a driver for it, right? And so in order to find the driver, what I'm going to do is go back to that peripherals library here. It's a Grove, this like rotary encoder. And what I can do is go and look for Seed Studio Grove. And then in there, look for rotary, let's see if I found it, rotary angle sensor, okay? That could be it. Otherwise, we might have, let me do a search here. Rotary, yes, we have actually one which is with button or simple rotary encoder. So I'm going to pick the basic one, and this is not specific to Grove. This is a very basic one. So I'll pick that. That's the library that is provided in there. You need to have Meadow Foundation as a NuGet package. That one is by default. If I were to, you know, extend with other peripherals, I will need to install additional packages. And then what I can do is just like go through the code and use that rotary encoder here and do something with it. So let's do that. Let's do that. So I have my application that will just require, there's no using statement. I just need to create an object of that type and then use it. Okay. So let's go do that in my application. Right. Okay. So in the class, I'm going to create, well, hold on. I need to do using statement. Using, and I will add Meadow Foundation, and I will add a sensor, and I will add the rotary one, right? That's the one we saw in the documentation. Here, I'm going to add my little rotary encoder. Okay, thanks IntelliSense that decides that, you know, what I'm doing. For now, that's going to be pretty much it. If I look at the documentation for the rotary encoder, in the function that is initiate one, I need to do a new, right, and set to the right pins, and then attach a callback to it, right? So let's do that. Actually, I can just go do that. That's going to be easier. So in the initialize function here, I'm going to do rotary encoder equals new, and here I'm going to have actually not this prototype, I want this other one here. And the pins I'm going to use, I need to check which one they are. By default, it picks analogs one, but I think I'm going to have digital ones. And in order to figure out which one are the right ones, I need to go back to the docs to see which pins are on this Grove connector here. So let me go back to here, and well, actually all the way up here to my Project Lab documentation, and on the GitHub page for Project Lab board, I have diagrams that will help me a little. So I'm connected on this little guy here, so I'm looking at D0 and D01, right? So these are the two digital pins that I have, in addition to power and ground, and this is where the signal for my rotary encoder will arrive from, okay? So let's get back to my application here. I set it up for D0 and D1, right? So my encoder is set. Now what I need to do is I need to attach the callback for when the event will happen on this little thing here. So if I go back to the documentation, or is it, it's down here, right? Okay. So the function is this one, rotary encoder rotated. And if it rotates clockwise, it's going to output something, and counterclockwise something else, okay? So this thing here, I'm going to copy paste down here. Okay. This little guy here is telling me, hey, you're missing some using statement. So it by default detected that the Meadow peripherals is the one that I needed for that, okay? And it says that value is not being created. So we'll generate a variable value somewhere, right? So actually, I'm going to do even simpler than that. I'm going to just put it here. Protected. Let's see, what does it need to be? It's going to be an integer, I think. Int. Value, and we'll start at 0. It's always good to set your variable here. Okay, so that callback has been set, and now I need to attach that in my init function just after creating the thing here, and that's it. Done. Boom. It was able to, let's see if that's the right one. Yes. Okay, done. Why is it not happy? Okay, no, should be fine here. So on the rotated event of this rotary encoder, I'm going to call this guy here, right? And this one, it doesn't like it. What's missing? Sensor is rotary. Okay, let's add that as well. We should be all good there. Like the IntelliSense that you get. I don't need Copilot for now. I need to hit F5 because I should be good there. Let's see what happens. Oh, start debugging. So it's gonna compile the app, hopefully with no errors, and then we'll deploy it. Okay, so things have deployed. Visual Studio is connected, the application is deployed and started. Let's see, I should have the right traces down there. Okay, we are in business, right? So now what I'm going to do is I'm going to grab the little rotary here. You see me on the device. I'm going to start rotating it and see what happens. And actually, I did a bad thing, which is I zoomed in with zoom in, and zoom it is not dynamic. Anyways, you can see it here, and you see when I go up, the value is changed. I scroll down, the value changes the other way around, right? So you have to believe me, I'm turning around, and you see the value is changing. So it was pretty straightforward to connect this grow sensor, get the code working with very few lines of code. I just created this class here, this instance of a class, Rotary encoder here, one line of configuration, one callback, and I'm in business. It's pretty straightforward. Just for the fun of it, I have a little servo here, right, which is controlled using PWM. I want to connect it to this other connector, which is a quick connector, which is a 4 wires connector as well, smaller, a bit smaller. That's one that sits at the bottom of this board here, so I'm going to do that, and we'll try and control it. Little servo is sitting there. So let's go back to the documentation here real quick. Where am I? I'll find this page again. This is the foundation part here. So remember, we search for this encoder here. Now what I'm going to do is search for servo. Oh, that's not the right one. So servo. Okay. So what do we have here? We can go I2C directly. Oh, look at that. Generic PWM generic servo controller. As simple as servos.servo, right? So that thing here is a new NuGet package that you need to add in order to have support for servos in there. So I'm going to just copy that. Go to my command line. I'm going to just add this package to my application here. Boom, boom, boom. And back to the documentation about the servo. And let's see how that works. I connected it to specific digital inputs. So I was telling you it's in this quick connector here. So I'm looking at D7 and D8 as the input, but I'm going to control using PWM. So PWM is going to be the 1 and 2 down there in green. So it should be these 2 ones. I just want to make sure. Okay, actually it's going to be on. It's PWM 1, it's on the D8. So actually, I need to pay attention to that D8 thing, okay? So let's go back to the documentation here to just do some copy-paste of code. Connectivity is going through that quick connector, pretty straightforward. I need to create a new object, just servo. So I'm gonna just create that guy here, or use my code. Here, okay, so let me add this little servo object here. Boom. It says, hey, I don't know you. Let's see. No, I don't want to add a servo. What I'm going to do here is do using Meadow Foundation servos, right? And well, that's interesting. Since I added the foundation servos, the rotation direction doesn't like it because there is an ambiguous description of it. So let's see if I can force it to, let's do that. I want to make sure that I'm using the one that I'm interested in, right? So that should be good, right? Rotation direction, clockwise. That's the one I need from the Meadow Peripherals namespace. Okay, so I solved this problem. That was like the same name for two different things in the two libraries I'm using, so we're all good there. Now, and eventually I could have just like commented that line, you would have forced it. But anyways, so that line is useless now. And we're good to go. So the servo object is here. I need to initialize it. If I go back to the sample, in the initialize function is one command, which is this little guy here. I'm going to do a copy of this command, go to my initialize function. And just after this little guy has been initialized, I'm here. I'm going to hook it up to the right pin, which I was telling you is D8, to have that PWM go over. And there are servos, different types of config here. That's interesting. And you see a collection of different servos. The drivers are adapted. I happen to have the most common one, the SG90. So I know that's the right one here. It's G95, I think, but that's the series. So here we have our servo that is all set up. So that's all I need. The servo is receiving commands, so it's waiting for a PWM command to make something happen, right? So I guess now the next thing I need to do is to set the angle of the servo based on the angle of the rotary thingy, right? The encoder. In order to do that, I will have to look in the documentation on how you set the angle, right? So there's a notion of rotate to with an angle, okay? So, and it's using a specific namespace for the degrees. Okay, let's see what I can do with that one. So what I want to do is go to my code. And here, basically, instead of just displaying the value, I'm going to rotate, sending the right angle to my servo here. And you see, I'm not dealing with the PWM signal at all in commands. You'll see that. What I need to set is a specific angle. So I'm going to do that, actually. I'm going to create a variable here called angle to make it simple, okay? I'm going to initialize that to 0. That's going to be the angle I'm going to set each time I have a clockwise or counterclockwise, okay? So I'm starting at 0. When I have like clockwise, what I want to do is I don't really need that for now. So I'm gonna comment that, and what I'm gonna do here is gonna be angle plus, okay? But the servo has a max and a mean, right? If I look at the sample is saying that, hey, you have to go to a certain, value, but not go beyond the servo config maximum angle in degrees, okay? So what I need to make sure is that I test this value of the angle to make sure that I don't go overboard here. As long as I'm lower than my servo config, I think it was config dot maximum angle, and in degrees, I think that was syntax here. I'm gonna do angle plus, okay? Now I'm gonna do the same thing the other way around here to lower this angle. If I am above the minimum angle, I'm going to do a minus. What do you think? I'm sure there's better ways to do that. And then what I need to do is do a rotate to with a specific angle, right? So I need to create a new angle. And that's going to be angle. Oh, sorry. And middle unit types. I think that's the right one, right? Degrees. Like that. Okay. And we are good to go. Let's see. Is that right? That is right. The thing though is I need to pay attention to the fact that this is a command that I'm sending to an async function, right? So I need to do that, and that should be fine. Let's see. Yep. I'm just doing the rotation of the angle, right? Yeah. New angle, blah, blah, blah. Well, we'll see what happens. I hope it's as simple as that. Let's do that. Redeploy the application. Okay, the app is on. I'm gonna show you a bit close up here so you can see what's going on. Hopefully when I turn this guy, oh, look at that. I can control the servo using my encoder. And if I go all the way to the max, it stops turning, go back, and it goes in the other way around. Gosh, I still know how to code like that. Okay. So you've seen that in very few lines of code, I was able to access hardware resources, control a little servo here, access data from an encoder that was coming on a digital pin. It was like super simple, like bringing the library, creating the class, the instance of the class, initializing it in one line of code, hooking a callback, and then I was in business. And for controlling the PWM servo here, I don't have to care about PWM. I have to care about bringing the right driver and tell the servo to go to the angle blah. And that was as simple as that. So I think personally, I think from the standpoint of a first-time experience, it went pretty well. Hello world in a few minutes. And then I was able to use hardware that I had like on a shelf somewhere, not used for some time, hook it up to the project lab board, and being able to do something that in a few minutes would have taken like way more using C, C++ code, Arduino, understanding PWM, and so on. So yes, there are plenty of libraries for these other platforms as well, but they are here in .NET. So as you can see, it's pretty straightforward. So I hope you enjoyed that. There's going to be more video here, so come back. wilderness lab.co. Once again, that's where you want to go if you want to learn more. Thank you.